that trick is not as good as the trick we're going to do here. So, all right. If you recall from last time, we started class with a polynomial. And we said, look, does this factor? We tried grouping. We couldn't do it. But I showed you that it does factor to be these three factors. And the goal was to try and to get to that. And then we looked at long division. And we saw that long division does give us a way of factoring. But the question was, where do we come up with the idea of what to divide by? And then we looked at synthetic division and said synthetic division is just a shorter version of long division, right? And so we had done these examples, is that correct?
Yes.
Did we finish them all?
Maybe. No, you went through and you just said that.
The ones we could and couldn't do, right? So
I know we did A.
We did up to C.
we did up to C. All right, so let's do D, all right? And just to get our brains going again. So how we do, we're going to do synthetic division on this. All right, so on D, we have x cubed minus 8x squared plus 8x squared, thank you. And then plus x minus 42 all over x minus 2. Isn't that the problem that we started class with? I mean, like, that's the one I said just a second ago.
Except it's minus x.
Was it?
That's what you put.
Was it up here? There it is right there, right? Did I write it down wrong just a second ago? I wrote minus, okay. All right, well, this is what I meant to write. Right before this, like with the how, it was supposed to be plus here. All right, so we're going to do this problem now. So what do we do for synthetic division? Upside down box, right? We put the coefficients inside. So what are my coefficients? 1, 8, 1, negative 42. And remember that we have to account for any spaces that you would have. Like if you were missing an x squared, you'd put a 0 in there. And then what number goes on the outside? Opposite of what's down here. So if we have a minus 2, we put a plus 2 down here. Or plus 2 over there. And then you just play this little game where you drop down, multiply, add, and do all that. So 1 comes down. 2 times 1 is 2. You add down. 8 plus 2 is 10. 2 times 10 is 20. Add down, you get 21. 2 times 21 is positive 42. And you get a remainder of 0, which is what we wanted, right? And now remember what this allowed us to do. With these three numbers, that actually represents our answer, doesn't it? So it's going to be a 1 sitting in front of x to what power? Squared, because we always go 1 power less than what's up here. And then we have plus 10x, so the power comes down. And then plus 21, so the power comes down again, right? And so what we can conclude is that this, right, is equal to this, right? So I'm kind of out of room here. This x cubed plus 8x squared plus x minus 42 over x minus 2 is equal to x squared plus 10x plus 21.
And then it factors 2x plus 3x plus 7.
We can then factor this, but I'm going to do one more thing before I do that. And also from last class, we said that if this divided by this equals this, right, then if we take this and put it next to this one, right, if we put the x minus 2 out here, then what we're saying is that this is equal to that. 15 divided by 3 is equal to 5 is the same thing as saying 15 is 5 times 3, right? You just bring the 3 to the other side like that. So do you all agree? And then Lily pointed out, right, Lily? Okay. Pointed out that this first one is a quadratic trinomial and it factors like AC method or something, whatever you're comfortable with, to be x plus 3, x plus 7, then we have x minus 2, right? And that's the answer of what I said earlier, like how are we going to get to that, right? Understand?
So how did we get that x minus 2?
So the only thing left for us to resolve is how did we know to divide by x minus 2, right? If someone started the problem like this and said turn it into this right here, we would have needed to know to come in with the x minus 2 and divide, right? Okay, so that's what the next note's about. How to determine what to divide by. All right? So I'm going to show you how it's done. The best way to do it is by examples. If I tell you the actual technique and write it down, it looks really ugly. If I just do it, it usually comes out a lot better. People understand it better. So you do need to know what it's called. It's called the rational zero test. Rational zero test. And I'm going to do the problem that we just did, I think. Let's see, is that my first example? Yeah. Here are the examples we're going to do. But let's start with this first example. X cubed plus 8x squared plus x minus 42. Now, before I apply the rational zero test, I want to talk about this test and its limitations. All right? Because there are limitations to this test. Are y'all okay?
Yeah.
Okay. There are limitations to this test. It doesn't always work. It only works if the answers that you get, remember how what we're trying to do is factor and set these things equal to 0 at some point? Yes, like x equals 2 or x equals 5. This will only work if you have rational zeros. So what is a rational number? We have to know what a rational number is. A rational number is any fraction you could possibly think of. So 2 is a fraction, isn't it? 2 over 1. Negative 5 is a fraction, right? Negative 5 over 1. 1/2 is a fraction. Negative 3/5 is a fraction, right? There's a lot of fractions. But there are a lot of numbers that are not fractions, such as what are called the irrationals, square root of 2. So if our polynomial, if the zeros it has are irrational numbers, this test won't find them. All right? It won't find them. So there's a limitation. Now, I'm not going to give you a polynomial that has a bunch of irrational zeros just to like be evil, right? Most of what I'm going to give you is going to work. But I want you to know there's a limitation. So I was showing you an example of one that doesn't work at the end. Right? All right. All right, so here's the test in action. You have to set up a lot of things first, all right? So you look at your polynomial that we're trying to factor. You make sure it's in descending order. So it's in descending order, right? We make sure we try and factor what we can right now. Like, is there a GCF? You know, we go through all the different techniques. We realize there's nothing we can do to that, right? What we do next is we identify the number in the back of the polynomial, which is usually going to be just a constant, all right? And let's just write that number down. And I really don't even care that it's negative, all right? I'm going to look at the number 42, and I'm going to put a colon next to it. And now what I have to do is come up with all of the ways, all the numbers that multiply to be 42. So let me give you some examples. I could have 1 times 42, right? So what I'm going to do is I'm going to say 1 and then 42. I'm going to put 42 way over here at the end of the list because it's going to be the biggest possible number I'm going to have. I'm creating a list of numbers. The next number I could have would be 2 and 21. How about 3? Does 3 go into 42? 3 and 14? Okay. How about 4? Does 4 go into 42? No. 5? 6? 6 and 7, right? And then at that point, I can stop. Why? Because they met in the middle, right? The next number I go to is 7. I already know 7 and 6, so that's it. As soon as the list meets in the middle, that's your list. Understand? But you could also get 42 by doing -1 and -42. or -2 and -21, right? So not only do you have all of these numbers positive, you also have all of these numbers negative. Understand? So your list is about to double. It's every one of these positive and negative. So right now I have 16 numbers total, right? That's the first thing you do, right? You look at the number at the back. The next thing you do is you look at the number, the leading coefficient, which is a number in front of x cubed, which in this case is a 1. All right? And you write that number down. And you create a list for that number. Now, lucky for us, the only number that multiplies to be 1, the only nice number, right, is 1 times 1. Yeah? Or -1 times -1. So we get two numbers there, positive and -1. Agree? Understand? Okay, so you create these two lists. One of them is big, the other one is only one thing, or two things. And now the final step of this list idea is to create the final list. The final list is going to be every possible combination of each one of these divided by each one of these. Now, we only have one of these, really, right? Positive and negative. We'll just say that that's one of them. So I have to take positive and -1 and divide it by positive and -1.
You get positive and negative 1.
You only get positive and -1, right? I could do 1 over 1, that's 1. I could do 1 over -1, that's -1. Or I could do -1 over -1, that's 1. Or -1 over +1, that's still -1. So there's only two possible things there, right? 1 and -1. And then I do 2, same thing, over 1. 2 over 1, what are the only possibilities? 2 and -2, right? And isn't that going to keep happening?
Yeah.
So aren't I just going to get that top list again? That will happen every single time that this was a 1, which I do on every problem for you except the last one. The last one's going to be a little bit more tricky. Understand? But just to make sure you're with me here, what if I had a positive or -3 here? What if I did? I would first do every one of these over 1, which would just recreate that list, wouldn't it? Then I do every one of these over 3. So wouldn't I get a positive or -1 over a positive -3, which would create a positive and -1/3, right? And then I would get what next? 2/3? What about 3 over 3? That's 1, I already have it in my list. So I wouldn't need to write it again. 6 over 3 is 2, I already have it in my list. Understand?
Yeah.
But I get to 7 over 3, that's not in my list, I would need to include that. All right? Now what if this had 5 also? Then you would also have 1/5, 2/5, 3/5, 6/5, 7/5, 14/5. I mean, your list could get pretty large, couldn't it?
Yeah.
Fast? All right. But for us, we don't have this blue part. We just have the original list. And how many numbers are in this original list? Total of 16. There are no questions here? No questions? Okay. We know that with synthetic division, it's a way of doing division. And if we get a remainder of 0, then we know that it worked, right? So what I need to do is I need to go through all of these numbers until I get zeros in synthetic division.
Yay.
So how are you going to proceed? What I suggest you do, and what I promise you will be the good thing for you on a test, is to always do them in order, smallest to largest. So we're going to do 1, then we're going to do -1, then we're going to do 2, and then -2, and 3, -3, then 6, and -6, until it works, okay? Okay, y'all don't seem very excited about this. All right, so we're going to set up the synthetic division. You ready? The numbers that go into my synthetic division are 1, 8, 1, and -42. What number do we know is going to work?
1, 2.
2's guaranteed to work. Didn't we just do this problem and we put a 2 out here?
Yeah.
Is 2 in our list? Yes, but it's going to take a little while to get to it, right? I want to show you the process because we got to act like we didn't know 2 is going to work. All right, so let's start with 1. Okay, 1 comes down. 1 times 1 is 1. Add down, we get 9. 1 times 9 is 9. Add down, we get 10. 1 times 10 is 10. And what's your remainder? Negative 32. That's not 0, right? Which means this failed. So just move on now. Well, let's see when we are going to stop. We're not going to do all 16, all right? Unless we absolutely have to, but we won't need to. Yes, the number of numbers that'll work should be equal to the number of factors that you have, most of the time. Let's see, yeah, okay. So let's go. Negative 1, right, would be next. And same numbers in here. We get 1, negative 1, 7, negative 7, negative 6, 6. And is it a remainder of 0? No? Whatever it is, it's not 0, right? So I don't care. So this is what I was talking about last class. You want to get quick with the synthetic division, right? Isn't it better than long division? I mean, if we had to do a long division on each of these? Okay, what would be my next number? 2. Okay, so let's go to 2 now. 2, 1, 8, 1, negative 42. And then now 1 comes down. 2, we just did this, didn't we? Yeah, 20, and then 21, and then 42, and then 0. Okay, now this is where things are going to be a little bit different than what we had done leading up to this, right? Because when we did this before, I gave you the original polynomial, and I said divide by what? X minus 2, and that is what told us to put the 2 here, right? What we're going to do is we're going to read this chart here a little bit different than what we did prior to this. What I'd like you to do, when you get to a remainder of 0, anytime you do, I want you to take this 2 down, straight down, and I want you to create the factor that came from. So what factor came from a positive 2 here? X minus 2, right? We know that came from x minus 2. With me? Because that's what it was. Remember with synthetic division? If we did that x cubed plus 8x squared plus x minus 42, and I said divide by x minus 2, then in synthetic division you said you would use a positive 2. So if I use a positive 2 and it works, then I know that x minus 2 has to be a factor. Understand? I'm going backwards from what I did before. That we also know can be moved to this side, right, like this. And it was just a matter of what was that other piece. But we said that other piece came from these numbers, right? Yes? So I'm going to put, I'll answer your question in a second, Lily, plus 10x plus 21. Understand? This number gives you one factor. These 3 numbers give you the rest of it. Question?
So when you get to the remainder of 0, and you can factor that quadratic, couldn't you just use that instead of having to go and do the rest of it?
Oh yeah, exactly. That's what I'm showing you here. See, we use this number to get one factor, right? We look at these 3 numbers and it creates the other piece, doesn't it? Now you ask yourself, can you factor this? If you can, you move on. I mean, you can go factor it. If you cannot, you have to continue with the synthetic division, which is more examples are coming, you'll see. Are there any questions, though, where I am with this?
So if you couldn't factor that, then how would you get the next division?
Hang tight. It's coming, all right? Baby steps here. We have to. So, but does anyone have a question on where any of this came from? Sure? So here's where I am. I know that the original polynomial, x cubed plus 8x plus x minus 42 is equal to x minus 2 times x squared plus 10x plus 21, which is equal to x minus 2 times x plus 7 times x, wait a minute, minus 20, was it? What was it? Oh, plus 3. Yeah. Yay or nay?
Yay.
We've factored it?
Yay.
It's factored. So we're done. So the synthetic division, even though we had 16 candidates for it, it only took us 3 tries to get it. And we were fortunate that what was here was doable. Now, yes?
So we're going to have problems that are going to be like,
There will be a problem where this won't be doable, so we'll have to continue with synthetic division.
So all we did was factor that one.
This one, yes, AC method type thing.
Okay.
Yes.
Pretend that doesn't factor now one.
Yeah, you're right, yes.
So because if it doesn't factor, that's saying that there's going to be another number that
In that list that should
that will
give you a remainder of 0. Yes.
since it did factor,
Uh-huh.
do you still continue with the other 6, or you
Nope.
stop right there?
Stop.
Okay.
The goal is to factor this, right? To factor, that's the goal. Our synthetic division applied one time. I mean, it took us 3 tries, but as soon as it worked, what remained was something I can handle. And so I broke it down, and now that's the factorization. Nothing else needs to be done. Yes?
So once you factor, you're done.
You're done. Yep, you're done. See, because now, couldn't I ask you to go back now and sketch that? To sketch that? So you would do the leading coefficient test, you would see what the behavior is, right? Then you'd find the x-intercepts, which in this case would take you some work. But now you could plot these x-intercepts, couldn't you? -7, -3, +2. What's the multiplicity? Touching or crossing at these? Crossing at all of them? And the leading coefficient test would have told us left side went down, right side went up. So it looks like this. See, we can actually graph it now because we can get the x-intercepts. All right, let's try the next one. This is a brand new way of factoring, okay? This is a new way to factor things, which is kind of nice. So if I put this problem on the board to start class out and I said factor this, if I put this up here on the first or second day of class and said factor this, most of you would have been hung up on this because it looks like a trinomial, right? A quadratic. So you might be thinking AC method. You might be thinking, yeah, I can just do this. But this is cubed, not squared, so you can't. It doesn't have 4 terms, so you can't do grouping. So you just don't ever see those before today, really. We avoid giving you something like that. But now with this new method, if there are rational zeros, we should be able to find them with this test. So first thing is to create the list, right? Make sure it's in descending order. The first number I'm going to look at is 20. What's the other number I'm going to look at? 1. And anytime we see 1, we already know that the list is really going to be just this first list. Okay? So let's write out the factors of 20. How about 1 and 20? And I'm going to go ahead and put plus or minus now because I'm going to wind up doing it later. How about 2? Does 2 go into 20? 2 and 10? 3? No. 4? 4 and 5? And we met in the middle, didn't we? Because my next number would be 5. I already did that. So I have a total of 2, 4, 6, 8, 10, 12 possible candidates for this. I could do the plus or minus 1, then recreate, but is everyone comfortable that my final list is this list because this is a 1? Okay, so this is my final list. And now I set up my synthetic divisions. I'm going to start with 1, then do -1, then 2, then -2, then 4, then -4, then 5, then -5, until I get a remainder of 0. What goes in the synthetic division? 1, 0, -21, -20. And what would happen if you forget that 0? You're going to probably be stuck. It's probably never going to work. So you can't forget the 0. Everyone comfortable with why the 0's there? You don't have an x squared term. All right, so what number goes on the outside? I'm going to start with the first number in my list, positive 1. Does it work? No. 1. 1 times 1 is 1. Add down 1. Times 1 is 1. Negative 20. Oh, no. It would have worked if it was positive 20. So that didn't work. How about negative 1? It does work? So we drop down, we've got 1. Negative 1 is negative 1. Negative 1 and negative 1 is 1. That's negative 20. Negative 1 and negative 20 is positive 20. Remainder of 0. Danielle? What should I write from this, Danielle?
Oh, it's x squared.
Okay, from here, start with this stuff. Tell me what.
Oh, drop it down.
Okay, so what do I put here?
X plus 1.
X plus 1. Do not forget this, all right? Do not forget you have to bring this one down. And don't forget that it's the opposite. The factor is the opposite of what you see there. And then go ahead, you said.
X squared minus x minus 3.
And then put that in parentheses, right? And now the question would be, can you factor this? Yes. So you're in business again, as long as you can factor that, right? What is it, x plus 4 minus 5? And you could say x minus 5 times x plus 4. It doesn't matter what order those are in. So from here to here is just factoring quadratic trinomial, and we're done. This is it, right? This is the answer. So look, I said this is a new way of factoring, right? And I know that there are some students that probably still struggle to get from here to here, right? Maybe. But let's just think about that for a second. If you're looking at this and you don't know that that goes to this, then theoretically, couldn't you just do what we just did? Like, couldn't you create a list and everything and go and start doing it? Couldn't you? And if you did, your list would be all the factors of 20, wouldn't it? Which is exactly the same list as the one we just had. Isn't it? So it turns out that what you could do is just continue applying the same list to this problem. So what number should work? Let's see if anyone can make the connection. What would be the first number that would work on that? In synthetic division, if I set this up and I put 1, negative 1, negative 20, negative 4 would be the first number that works. Because I know this breaks down to be this and this, right? So if you go through the list on that, the first number that will work would be negative 4.
And then it goes straight to that.
And so watch what will happen. If you go negative 4 out here, you get 1, right? Negative 4, this is negative 5. Multiply here and here, you get 20. You get a remainder of 0, don't you? And then if you follow the same process, this would give you a factor of what? X plus 4. And then these two remaining would give you the rest. And what would the power be? 1 less than that. So it would just be x minus 5. And that is this. So you could completely get around the AC method and use this. You could have done that to begin with. Yeah, but you want to be the type of student that's, if you're going to go on electrical engineering, you want to be able to factor that in your, mentally as opposed to requiring that. But that's kind of like a fail-safe. It's a backup plan. All right, let's go with the next one. Ooh. All right, the next one, x to the 6th minus 3x to the 5th minus 11x to the 4th plus 3x cubed plus 10x squared. So the instructions on these are to factor, right? That's what I'm trying to do. So let's move around. Yeah, we have a GCF. Everyone see that we have a greatest common factor to start the problem? Okay, don't get all gung-ho and start doing your synthetic division now and creating your list. First, always try and see if you can factor it. So I'm going to pull an x squared here. Be left with x to the fourth minus 3x cubed minus 11x squared plus 3x plus 10. That's what that's equal to, right? And when I look at this, the only part of this I still don't know is everything in the parentheses, right? That's the part that I need to factor now. The x squared's already out there. Do not forget about the x squared. It's part of our answer, right? But that piece right there, there's no technique of factoring that you've learned before that will work on this, except for what we're about to do, right? 5 terms, no one ever gave you a method for 5 terms. So I have a list, right? What are the 2 numbers that I'm going to create my list from? 10 and 1, right? And since it's a 1 again, I got very lucky here, right? That's a 1 right there. Really the only list I have is for the 10. So plus or minus 1 and plus or minus 10. What else? 2 and 5, that's it? Not so bad. With 8 potential answers here. The numbers that go in here are 1, -3, -11, 3, and 10. And I'm starting with what number? Positive 1 on the outside. So I'll give you a minute or two to see if you can get the rest of this on your own. Did it work the first time?
Yes.
Yeah, that saves you a little bit of time there. However, x cubed yeah, well, I'm going to bring that back in a minute because I'm still not done. You see why I'm not done? Okay, yeah, let's make sure everyone's with me here. Is everyone at the same spot? Tried one, it worked out, you got a 0, and then we're able to reproduce this line?
Yes.
So I know that this stuff in blue, right, just the stuff in blue, not this blue thing becomes this. But what's in this parentheses doesn't factor, not right away, because it's 4 terms, 1, 2, 3, 4. So you could try grouping, but grouping is not going to work on this. You can try it yourself, but it's not going to work. So what do? We're going to do the rational 0 test on this, right? Now here's kind of a, not a shortcut, but just to keep in mind. When you do this one, you do not need to create a new list. You can use the same list you had. But you must start with the number you stopped with. Now, in other words, we used 1, right? And it worked. That means when I start synthetic division on this, I need to start with 1 again, because it could work twice. It does? Okay, that's the key. If you say, oh, I already did 1, now I'm going to move to -1, you might miss an actual answer. So I'm going to continue. Do you all understand? I'm going to continue now. I need to erase this. I'm going to continue synthetic division on this piece here, which is now 1, -2, -13, -10, and I'm going to use 1 again. It doesn't work? Oh, someone said it worked. -1 works? Okay. But you have to do 1 because it could have 2 factors of x minus 1. So 1, -1, Yeah, that one gives you negative 24, so that one didn't work. Are y'all with me or not?
Yes.
Yes? Okay. So I'm going to go again now. 1, negative 2, negative 13, negative 10, and I'm using negative 1. Let's see, 1 comes down, negative 1, negative 3, 3, negative 10. Yes, there we go. 10 and 0. So what does this tell us? We have x plus 1, x squared minus 3x minus 10. And so the question becomes, can you factor this?
Yes.
Yes. Hopefully. X plus 2, x minus 5. So I'm going to put x plus 1 times x plus 2, x minus 5. All right, are we ready for a final answer?
Oh, yeah.
Oh, yeah, everything else, right?
We have to make sure we go back and get everything, all right? So where did we start with? We started by factoring out an x squared. Then we got to this line, right? We had an x minus 1. All of this junk right here just turned into these three, didn't it? So we have x plus 1 times x plus 2 times x minus 5. That's the answer. How many x-intercepts would we have here? How many x-intercepts? 1, 2, 3, 4, 5. That one would just be a bouncing one, right? These would be touching. This would touch. This would cross, 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 right? Yes.
So when we go to graph it, we go off the multiplicity of that factor right there?
Yes.
Okay, not anything before.
That's right there.
Okay, so that's why they don't.
So just out of curiosity to see how quickly you could graph this, I would have x-intercepts, let's see, at 0, 1, negative 1, negative 2, and positive 5 out here. Do we agree? What about left and right behavior? Always go for that. So you have to go back and look at the original polynomial, which was, we're doing C, right? So degree is 6 and positive leading coefficient up on both sides. And I'm going to cross through, right? I'm going to cross, 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 touch, right? So starting from the left side, it's going to go down. It's going to cross through. It's going to cross through. It's going to touch. It's going to cross through. It's going to cross through. That would be the general look of it. Yes?
X squared is just going to be 0 then.
Yes, you're setting, because this factor right here, this always trips people up because they want it to look like this, right? That is actually x minus 0 squared, isn't it? So I don't know. I think that we've made some progress, right? I mean, look at C. If I asked you to sketch that function, that would look pretty intimidating, right? To sketch that, but I mean, it's really not. Once you can break it down, it's not that bad. All right, I'm going to look at number 5. Yeah, I meant to say D, actually. I don't know why I said number 5. I guess because it's to the 5th power. All right, so we want to kind of turn it up a little bit here as far as the speed of how fast we're going through this, all right? What's the first thing I'm going to do? Take an X out. Be careful. Do you all see this? Do you all see the gap in there? Yes. Yes? right? There's a gap in the powers there. All right, so the piece that's in the parentheses, I'm going to need to do my synthetic division, my rational zero test on that. What's the list I'm going to have? The 12 and the 1, right? Again, the 1. So we're happy about the 1, right? Because really it's all the factors of 12. So my list, my final list is 1, 12, 2, 6, 3, 4. I set up my synthetic numbers. Numbers? 1, 0, -9, -4, 12. Okay, I just want to make sure everyone got that 0. This is usually the time where someone gets ahead of me and tells me what works. But oh, 1 works? Y'all are getting lucky here today. Yeah, 1 works. Okay, now I want to. Y'all seem to be following me pretty good here. I wonder if I could take you this far. I usually don't do this, but can you visualize what's going to happen here? This is going to come down as what? X minus 1. Then we're going to have x third because this was the 4th power, right? Don't be looking up here because we pulled an x out. So this is going to be x cubed, x squared, minus 8x, minus 12. This is going to have 4 terms. Can you factor that by grouping? I don't know if you can see that far ahead or not. No? It's not going to work because these two, what's the only thing you could factor out of an 8 and a 12? A 4. So if you pull like a -4 out, you'd be left with like an x minus 2. But this would not be an x minus 2. You'd be off. So it won't work. So you're going to have to do it again, right? So see if you like this or not. If you want, you can write x minus 1. You could write the whole thing out. But if you have to do synthetic division on this again with the same list, then why don't you just do synthetic division again right here and put your number right here? That's a little much? Okay, then we won't do it that way. All right. You might see that if you go like in the tutoring lab and stuff, they just keep on attacking this thing. And you get this big crazy synthetic division thing.
You just did your entire list. So if you did your entire list with this, it would work, right?
Well, as long as it has rational zeros, it would work. All right, so we're going to just do this, right? We're happy with that? Okay. This doesn't factor. I create a new synthetic division. Where do I start with my synthetic division? Where do I start? 1 again, right? I have to start with 1 again. But my numbers are different. 1, 1, -8, -12. Does 1 work? Oh. -1 doesn't work either? Okay, keep going. -1 doesn't work. 2 doesn't?
2 doesn't, but -2.
Okay. I want to show all the ones that fail, so I'm going to put them up here. I'll catch up with you in a second. Two doesn't work. I won't do, on a test, you won't ever have to do the synthetic division more than like 4 to like 20 times. No. Like, usually like 4 or 5 times at the most is what I go for. As long as you put them in order and do them in order. If you decide to like start somewhere else in your list, I can't promise you anything. Yeah, if you start from the back, that's on you.
Since 2 worked up there.
2 did not work. -2 worked?
Oh, yeah.
Okay, so this is going to come down and become x plus 2.
And then this here, factors,
Okay, I'll get to that right here like this.
yeah, and then that factors.
X plus 2, x minus 3. So you're going to have two x plus
So
2's, right?
Yeah, that was my question. Do you keep both of them? Or do you?
Yes.
Okay.
Yep, you have to keep them both. We're going to put x plus 2 squared. Yep. So let's see, can we put this all together? The first thing we pulled out was an x, right? And then since I've already erased it, didn't we have an x minus 1 factor? And then what was left, we just got to be this, right? Which was x plus 2 times x plus 2 times x minus 3. But if you notice we have a double factor here, so you need to put those together because that will dictate your what? Your crossing or your touching, right? Your multiplicity. So since there's two of them here. Also, I'll point out that that's why if you have to repeat the process, that's why you have to try the number that worked again. Because this says that negative 2, right, should work twice because there were two factors. So that's why if you ever have to repeat the process, always pick up where you left off, just in case that number works again. Questions?
If you're going to put that in descending order, would it be x first or x plus 2 squared?
There's no such thing here as descending order when it's factored.
Okay.
It's only when it's expanded out that there's a descending order.
So it doesn't matter which way.
Doesn't matter which way you write that.
Graph that?
Sure.
In the homework, is it going to require us to graph it?
I don't know. I'll look at it. I don't remember what it says. What are my x-intercepts here? 0, 1, negative 2, positive 3. And I'm going to cross here, I'm going to touch here, I'm going to cross here, and I'm going to cross here. And what about the left and right hand behavior? Down on the left, up on the right? So, and the only place that I touch at this one, right? So I have to be kind of careful here. I start down on the left. Wait. Set that equal to 0.
Oh, okay.
So I'm setting each of these. Remember, factors are different than zeros. The factors are what you have to turn into a 0. So you do the opposite, what you see there. So I need to come from the bottom up. I need to actually touch the, oops. I need to actually touch here. And then from there, cross through, cross through, cross through. So that's what it would look like. If we sketched it, that's the general look of the graph. All right, let's skip to F. All right, let's skip to F. Unless y'all want to do E.
Let's do after.
Maybe I'll let you do E on your own in a minute. Maybe as an in-class quiz? Or do y'all get mad when I give you quizzes over stuff that we just talked about?
No.
That's your favorite type? I had a comment on one of my old students commented on, I forget where it was, but they're like, yeah, he has the audacity to give us a quiz on the same day over the material we just covered. They got all upset. So I don't want to upset you, you know. If you want a quiz over this.
You can take a vote if you want to.
All right, I'm going to hold you to that. Plus 17x. Liz, what are you doing over there, Liz? That's what you do when you're bored? Okay. All right. Well. You can pull a negative out. You don't need to, though. I mean, I would say, because if you look at a polynomial, you can always pull any number out. It doesn't matter. Like, I could pull a 5 out of this. And no one's probably ever seen that, but.
It'd be horrible.
No, but this is something you do in calculus. I'm just showing you, okay, that's all. I'm just making a point here. I could pull a 5 out of that. I mean, I could. I could pull a 5 out of that.
I mean, you could if you hated us.
I'm making the point you can pull any number out. So if it doesn't have an x, don't bother with pulling anything out. Okay, so 4 terms. You might try grouping. It's not going to work. So you have to create a list. Now, this is different now. All right, this is why I'm showing you this example. Because you have 30 in the back, you're going to create a list out of that. 1 end 30, 2 end 15. Uh-oh, I may not have given myself enough room here. 3 end 10. 4? No? 5? 5 and 6. Okay, so I have enough room. But this is not your final list because you have a -2 in front. And because of that, we're going to put 2 and list all the factors of 2, which are only 1 and 2.
So technically, isn't it the same list?
It's the same list. You're always going to have this same list because it's always going to be that. You're always going to have a 1 here. But it's a question of, do you have anything else? So let me create my final list. I'll keep that up there. Final list. It's going to be the original list. I know you all like partial credit, so on exams, when I'm asking you to do a problem like this, writing the list out will give you some credit. If you mess something up later, at least you get something for getting a correct list. But don't skip the list, all right? Some people will just skip it and be like, well, I just know I'm going to use 1 and then 2 and then 3. Write it all out. Well, yeah, that's okay. Got to show some work, though. Like the synthetic division, you need to show that. Okay, so this is the first part of it. Now, it's every one of these numbers, right, divided by 2. So 1 over 2, that gives me 1/2. 2 over 2 is 1. I already have that. 3 over 2, 3/2. That's not in my list. Now it is. 5 over 2, was that in my list? Nope, so 5/2. All right, 6 over 2 is 3. Was that in my list?
Yeah.
Yes, I don't need it. 10 over 2, got it. 15 over 2, no. 30 over 2, is 15. That's in my list. So that's it. That's the final list. So I have now 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 possible candidates. Yes?
Would you be able to change it to like decimal points?
You could, yes. But I would leave them as fractions at least in your list. Now, the question becomes, what do you do first? So on a test, I recommend you just wait on the fractions. Just go through the nice numbers first. All right?
He's telling us that so that we'll go through all of those numbers.
No, because I said on the test, I promise it's going to happen within the first couple of tries. But if you start with your fractions, no more promises. All right? All right, let's try it. All right, in the synthetic division box goes -2, 3, 17, -30. Is it what? Anybody get it yet? Anybody ahead of me here?
1 and
What number
-1
works?
don't work.
1 and -1 don't? 2 works?
Nope.
2 doesn't work?
I get 0. I have a factor.
Okay, but you're getting a 0? Let me try 2. -2 comes down. -4, -1, -2, that's 15. Yeah, 2 works. So look, I'm skipping over 1 and -1. You understand you would have to do that first, right? And then they would both not work, I think. So this would give you x minus 2. And this will give you -2x squared minus x plus 15. And now it's a question of whether or not you can factor this or not. So some people might have some trouble with that one. Does anybody know how to factor that one mentally? Can anyone do this one mentally? No? Just trying to see where we are as a class. Can anyone do this one mentally? It's a quadratic, right? AC method? No? No one?
2x plus 5,
It should factor.
and then x minus
Let me do it real quick over here. But I'm gonna, obviously no one feels super comfortable with this. So we would need to do the synthetic division again, wouldn't we? But let me see if I can figure out what it is. Negative 2x and x, that'll give me the negative 2x squared. 15, the only factors I have are like, I can do 5 and 3 and make them both positive. I'm trying this, I'm doing like a mental guess type thing. This gives me negative 2x squared, but then I get what? 10x and negative 10x and 3x, that's not it, right? I need it to be a negative x. You said switch them, does it work?
Yeah.
If I switch this to a 3, and I switch that to a 5, and that gives me negative 15, hold on. Minus 5 here, and then what?
X plus 3.
Can't be plus 3 because it's plus 15.
Well, it is plus, isn't it plus 5 plus 3? Because 3 by negative 2x equals negative 6x plus 5x, that's negative x, and then 5 by 3 is
Yeah, that's right. Yeah. So this works, but look, hold on. It doesn't appear that many of you would have got that right quickly, all right? So can you tell me now what would have been the next number in the synthetic division that would have worked? Negative 3 would have worked. So where were we in our synthetic division? 2? You would have picked up with this one, right? And you would have tried 2 again, it would have failed. You would have tried negative 2, it would have failed. Then you would have tried 3 because it's the next thing in your list, right? Let me put that up here because I want you to see that work. If you would have done this, negative 2, negative 1, 15, and you would have done the 2 again, fail, negative 2 again, or negative 2, fail, 3. Is it 3 or negative 3 it's going to work? 3? Negative 3? It was x plus 3, right? So negative 3, sorry, would work. So 2 would fail again. 2 would fail, negative 2 would fail, 3 would fail, and then negative 3 should work. So let's see. Negative 2, multiply here, we get 6. Add down, we get 5. Negative 3 times 5 is negative 15. We get a remainder of 0, right? And then this tells us x plus 3, and then negative 2x plus 5, which is exactly what I had written up there a second ago, right? So can we write our final answer up here? This is equal to, we had originally pulled out an x minus 2, right? And then we had these two pieces right here. All right. Okay? Can anyone tell me what other number would have worked out here? What would it have been? We know that 2 works from this, right? We know that negative 3 works from this. If we set this to 0, solve it, you get x is 5 over 2. That should have worked in synthetic division also. Was that in our list? Yes. I'd like to show you that number work, just so you can see it for one time. How would a fraction work in the synthetic division? Just to show you. So I'm going to start from here.